All right, today's lesson is on properties of proportions. This skill is going to be so essential when we move into our unit on similarity. So first off, I'm giving you a set of statements and I'm asking you which ones are true. Now, when you first learn about fractions, we show you this visualization approach. So for example, right here. Here I've drawn a circle, I've divided it into two equal parts, and I've shaded just one of those two parts. Right? So this is a ratio of 1 to 2. Here I have a circle that is broken up into 4 equal parts, and I've shaded 2 of the 4. Now that also reduces down to a 1 to 2 ratio. Okay, here I have a circle that's divided into 10 equal parts, and I've shaded 5 of them. Right, 5 to 10, still 1 to 2. And if I get even bigger, right, here's my circle, I've split it into 20 equal parts. I've shaded 10 of those 20, it is still an equivalent ratio. It is still 1 to 2. So when we end up building these proportions, like we're seeing in these examples A through D, right, I'm just saying, are those ratios true? So 1 to 2, is that the same as 10 to 20? I just showed you that it was, right? 10 to 20 reduces down to 1 to 2. So absolutely true. Okay, the next one, I just wrote it in a different way, is 1 to 3 the same as 5 to 15? Well, yes, right? 5 to 15, if I divide by 5, 5 by 5 is 1. If I divide 15 by 5, I'm back to 3. It reduces to the same ratio. So also true. Okay, 12 to 48, is that the same as 1 to 4? Well, I could divide 12 by 12 and 48 by 12, and it would make 1 to 4. Now, I could also think of going in the opposite direction. If I multiplied 1 by 12 and 4 by 12, I could get back to this 12 to 48 ratio as well. Also true. Okay, 6 to 30, is that the same as 1 to 5? Well, if I take 6, divide by 6, and 30 divide by 6, I'm at a 1 to 5 ratio, so yes, also true. So in all of these, I gave you true statements, and they're true because the ratios balance. Okay, so now here's where we're going to use it. Here I'm telling you that triangles are similar, and if I say similar, that means that they are the same shape, but different sizes. So you can take a shape and you can enlarge it, or you can take a shape and you can shrink it down. But to be similar, they are the same shape, but they are just different sizes. When figures are similar, corresponding angles are congruent, and corresponding sides, they are proportional. There's that word, proportional. So if I say proportional, that just means they have the same ratio. Okay, and we can use that information to solve for x in these two problems below. Now, before I go further, I want to point out that we often talk about a scale factor that we call k. So k is our scale factor. We think of it as a multiplier. So a value that we can use to multiply each of our sides by to have our figure enlarge or shrink down. Okay, so looking at A. So first let me note what the corresponding sides are. So right here, we've seen them with the same orientation. So here's a pair of corresponding sides. And here's my other pair of corresponding sides. And I want to use that information to get to x. So I'm guessing that we can all see that to get from 4 to 8, right, 4 to 8, we must have multiplied by 2, right? This shape, all of the sides then must be doubling. They're getting multiplied by 2. My scale factor is 2. So it can be that simple. I can say, well, 4 times 2 is 8. So 5 times 2 gets me to 10 right here. X is 10. Pretty simple. But another way that you can solve is you can build a proportion. So I could say something like 4 is to 8. I'm just linking up the corresponding sides as 5 is to x. And once I've built this proportion where my ratios are the same, I can cross multiply to clear fractions. Okay, so cross multiply to clear fractions. So here I can multiply then the 4 by x, so 4x, the 8 by 5, which is 40, and now I have an equation of 4x equals 40. And then I just divide by 4, and I get that x is 10 a different way. Now, I have no problem at this point with you using that visual approach of seeing what the scale factor is and using it as a multiplier. That's fine. If I was going in the opposite direction, if I was going from 8 to 4, I could see that, oh, if I was shrinking it, I can see that all of these sides here are half of these sides over here. So it really does depend on your directionality. Are you enlarging something? Are you making it grow bigger? Or are you shrinking it down? All right, the second one here I'm saying, again, triangles are similar. So let me link up those corresponding sides. So I can see that this side links up with this side right here. And then this side to this side right here. Okay, so if I'm thinking of my scale factor, right, I'm somehow getting from 9 to 3, hopefully we can see that that's going to be 1/3. Let's say that you didn't see that. Another way that you could solve for it is thinking of your scale factor as the ratio of new to old. So since I'm moving from here as my original to this new figure here, if I took 3 and divided it by 9, it would confirm that 1/3. Show you that work, right? 3 to 9 reduces to 1/3. So it just confirms that 1/3. Some of them you can just see. So there's my scale factor. So again, 9 times 1/3 is 3. So 12 times 1/3 would get us to 4 right here. X is 4. So that's one method that you can use, and you can also build a proportion. You could say that 12 is to x, right? 12 is to x, just as 9 is to 3. And if you cross multiply, you'd get 9x equals 36. And then divide by 9 and get that x is 4, a different way. So you can always build a proportion, or you can recognize the multiplier and do it that way. Either way is fine. All right, next up, I'm just giving you a bunch of proportions and saying, can you solve for x? All right, so the first one here, I have 4 to x equals 2 to 5. So if I cross multiply here, I would say that 2x equals 4 times 5. So 2x equals 20. Okay, and then from here, I would divide by 2 and get that x equals 10. All right, and if I look at it back, is 4 to 10 the same as 2 to 5? Yes, it is. Okay, next one here, again, we cross multiply. So I'd say that 7 times x plus 3 equals 4 times 2, so 8. Okay, next I would probably distribute the 7. So I get 7x plus 21 equals 8. Okay, and then I would take away the 21 from each side. So 7x equals a negative 13. And then divide by 7. Okay, so here I get negative x over 7. No, I'm sorry, x equals negative 13 over 7. X equals negative 13 over 7. And you could leave it like that, or you could leave it mixed. So x is negative 13 over 7, or right? I could write it as x equals negative 1, because 7 goes into 13 once, with 6 left over out of 7. That would be fine also. All right, 2 more, and then we are done. All right, next one in C. Here, when I cross multiply, when I multiply an x by x, I get x to the second power. So I'm cross multiplying. X times x is x squared, and then 6 times 12 is 72. Okay, so now here I can solve by taking the square root. So square root, square root. Okay, look at that 72. I can see that it's 36 times 2, and 36 is a perfect square. It gives me a pair of 6's, but that sweet little 2 is going to stay behind. So my answer here, I got to remember that it's going to create 2 solutions, a plus or a minus, because when I have a quantity that's being squared, it could have been negative or positive. Squaring it will make it positive. So plus or minus 6 root 2. Now in this instance, if I put a 6 root 2 back here that's both positive, it will work, and both negative, it will also work. Both of these solutions algebraically do work. So I need to write my answer with both of those choices. All right, one more. So here again, I see I have to cross multiply, and x times x gets me x squared. Now here, when I cross multiply, I have these 2 binomial packages. I have an x plus 3 and an x minus 2. Now, whichever order you write them is fine, but I still have to multiply them out. I have to FOIL them out. Okay, so here I still have the x squared on the left, and on the right, here's my first, x squared. Here's my outer, minus 2x, my inner, plus 3x, and my last is minus 6. Okay, clean it up, combine these like terms. X squared equals x squared plus x minus 6. So I see that those quadratic terms, they're going to cancel away, because if I subtract x squared from one side, it's going to clear from the other side too. So I have 0 equals x minus 6. And I want to solve for x, so I'm just going to add the 6 to the other side. I get 6 equals x, but remember that symmetric property lets me flip it around and say that x equals 6. Okay, we're done for today. Good little intro to proportions and seeing that we're just looking at equivalent ratios and using different strategies for solving for a missing side in similar shapes, and then just the pure algebraic skill of solving a proportion for a missing variable. Have a good rest of your day.